Okay, this is Math 7, Chapter 4. This is Lesson 5 Extra Practice. It's just a nice big old worksheet that your teachers passed out to you sometime this week probably. And it's practice working with adding and subtracting mixed numbers. We're going to go through this process today of adding and subtracting and then writing it in simplest form. And so I'm going to do a few of these problems here, not all of them, but a few of them, just to kind of help guide you along in your homework. So if you get stuck on something, you have something to look at. So let's take a look at number 2 first of all. I'm going to start there. Number 2, I'm going to write mine on a piece of paper down below here just so I have more space. It says that I have negative 5 and 2/7 minus 2 and 3/7. What I want you to think about here first is let's write this without the fractions for a second. If I had negative 5 minus 2, and I go back to what I did in maybe my first week of school or so, not worrying about the fraction part. If I have a negative minus 2 here, I want to turn this subtract 2 into add a negative. Once I do add a negative, now I have a negative and a negative, and I'm going to add them together. So if I had the signs being the same, right, the signs are the same, then I'm going to find the sum, which means I'm going to add those two things up. So if I was just working with the whole numbers, it would be a 5 plus 2, which is 7, and I'm going to keep the sign the same. Right? So it's a negative 5 plus a negative 2 is a negative 7. So knowing that it's because of the same sign, I'm just going to add. I can now take a look at my fraction and do what your teachers have probably said to do, which is go ahead and stack them. I heard that in class the other day. So I have a negative 5 plus a negative 2, and I put my fraction here, 2/7 and 3/7, and because I'm going to add these things together, I can go ahead and begin by looking at, just like in our old school stuff, I'm going to start here with the fraction side. On the fraction side, the denominator is the same, so that's good, which means I'll have the same denominator here. Now I add the numerator. 2 plus 3 is 5, and now I'll add up the negative 5 and negative 2 for a negative 7. So my solution for number 2 is negative 7 and 5/7 is what I get for number 2. Okay? Let's take a look at number 3. For number 3, I have a positive and a positive. So again, if I wrote that out horizontally, this would be like saying, what is 6 plus 7? If I did 6 plus 7 normally, I would say it's 13. So I should be looking for something around that as a solution. Let's take a look then. I'm going to take my numbers, and I will stack them up. Okay, I'll go ahead and write on my paper right here. I have some space after all. So if I do 6 and 3/8 plus 7 and 1/8 and draw my line there, then what happens is I start with my fractions. The denominator is the same, so we're okay. 3 plus 1 is 4. Denominator stays the same, and 6 plus 7 is 13. So I have 13 and 4/8, which is pretty close to the answer, except that I do want to simplify this. I recognize that 4 times 2 is 8, so actually, if I divide both parts by 2, for my fraction part, I end up with 13 still as my whole number, and 4 divided by 2 is 2, and 8 divided by 2 is 4. Oh, I can keep going. Oh my goodness. Let's divide by 2, and I end up with 13 and a half, which you might have seen a little faster if you went, oh, 4 is half of 8, so I could have divided the whole thing by 4. Let's take a look now at just some setup things real quick. On number 4, not going to solve it here. This is a lot like number 2, but let's look at the setup. I really have a minus 2 minus 1, right? If I rewrite that, it becomes add a negative. Now my signs are the same, so I'll find the sum. So what that means is we're going to go ahead and actually take these, and when we stack them up, 2 and 3/4, 1 and 1/4, I can go ahead and add them, which is just fine, but need to remember that my solution will be a negative solution. So I can go ahead and add that up. Well, I have 2/3. I don't know any idea. 3/4. Sorry about that. 3/4 and 1/4. So when I add that up, I can add this part, add that part. I just need to make sure my answer is negative. Let's look at number 5. For number 5, I have 5 minus 3. If I didn't worry about the fraction part, if I just did 5 minus 3, I have 5. Take away 3 is 2. So my answer should be less than 5 and probably less than 3. I'm going to get a small answer here. But let's take a look at what's going on because there's more happening here. For the first time, I have denominators that don't match. So when I write this out, I have to worry about the fraction part. So I'm going to put my larger number on top, 5.5, and I'm just going to do regular subtraction of 3 1/4. Okay, so I have 5.5 minus 3 1/4. Okay, now I need a common denominator here. I know that 2 times 2 will get me 4. And if I do the same thing to my numerator, 1 times 2 is 2. And now I'm in good shape here because this part, a half, I can rewrite as 2 over 4. I'm just going to lightly shade that out just so you know it's kind of gone. I'm not worried about it anymore. I've converted it to 2/4. Now, to do subtraction, I need to have the larger number on the top. In this case here, 2 is larger than 1, so I'm okay to go forward. So 2 minus 1 is 1, and the denominator always just stays the same. When we're adding subtraction fractions, the denominator stays the same. And over here for our whole number, 5 minus 3 is 2, and that is actually the solution that I'm looking for. There's nothing else I can do to reduce that. It's just how it is. Okay, let's look at number 6. Number 6 is a great problem. When I look at number 6, what I see is, pull my paper there real quick. If I wrote this out as whole numbers, it's asking me a minus 2 plus a 4. Okay? Minus 2 plus 4, if I wanted to, I could rewrite this, couldn't I? I could change the order around a little bit. I could do a plus 4, or a 4, and then do minus 2. Well, do you know how to do 4 minus 2? I would imagine you do, because 4 minus 2 is simply 2, right? Here's 1, 2, 3, 4, and I take away 2. So on this problem here, what I really can do is I could say, well, instead of thinking about it as negative 2 plus 4, I'm going to switch it around and rewrite this as 4 1/9 minus 2 2/3, because that just makes a little bit more sense to me. I didn't change anything, I just changed the order in which I stacked them. I put the larger number technically on the top, and then I subtracted the little number because it has a minus in front. To solve this here, I need a common denominator. So I look here and I have a 9. When I think about my 3s, I know I have 3, 6, 9. Oh, 3 goes into there. If I multiply this by 3 and the top by 3, 3 times 3 is 9, and 2 times 3 is 6. Now I have a common denominator that I can work with here to do the subtraction. So I can get rid of this part, just kind of shading it out like it's gone. But when I go to do my subtraction, what do I notice? 1 minus 6. I can't do 1 minus 6. If I only have one circle, can I take away 6? Nope, can't do it. So I need to borrow, back from what you used to do as regular subtraction, from the guy next door. So I go to the guy next door, the 4, and I'm going to borrow 1 from the 4. So instead of a 4, he becomes a 3. And now when I'm borrowing actually a whole pi, a 9 out of 9 pi. Okay, I'm borrowing a whole pi to make this work. So I didn't just borrow 1, I borrowed 1 whole, but what is a whole? 9 out of 9, because this is equal to 1. So now let me add this up. 1 plus 9 is 10, and denominator is still a 9. Now when I look at the subtraction part, right, I can kind of shade that out now. I have 10 minus 6, which is 4. The denominator stays the same, which is 9. And 3 minus 2, 3 minus 2 is 1. Alright? So I have 1 4/9 for number 6. Okay? How are we doing so far? Doing okay? Alright, let's keep on going. Let's write this down here, right here. 1 4/9. Put that guy right there. Alright, let's move down to number 8. Okay. On number 8, another good problem here. Again, thinking about it just as a regular problem without the fractions, I would have 3 plus a minus 5. Right? So this becomes 3, and I'm taking away 5. That's kind of a little weird there to think about, but that's what it's asking me to do. All right. So when I have something where I have the signs are different, okay, when the signs are different, I find the difference. But then I have to keep the greater absolute value sign. Whatever one's bigger, I keep that value. So in this case here, my solution should be negative. Whatever I get, I'm going to have a negative answer. So I know my answer is negative, but I also remember from back in elementary school when I used to do subtraction, I always want to put the bigger number on top. Okay? So let's just hang on to that negative sign for a moment and not worry about it right now. And let's pretend that these are two positive, or we're going to do a positive minus a negative, because again, I want to do the difference. So I'm going to set it up like this: 5 5/8 minus 3 3/4. Okay? I'm going to do that because I want to find the difference, and I put the larger number on top, or at least what looks like the larger number. And I'm going to find the difference means subtract. Okay? I know my final answer will be negative, so I can already put that in there if I chose to. And now let's take a look here. 5/8 3/4. To get the 4 to become an 8, I'm going to multiply it by 2. Alright, so 3 times 2 is 6, 4 times 2 is 8. Can I do 5 minus 6? I can't do 5 minus 6. Doesn't work there. So I need to borrow from this guy, which makes it a 4. And I'm going to add to it a whole 8 8s. 5 plus 8 is, what's it going to be? 13 over 8. Now I can subtract 13 minus 6 is 7 over 8. And 4 minus 3 is 1. And I got to remember this whole thing is negative, so I end up with a negative 1 7/8 for number 8. Okay? A little bit tricky there, but again, think about what it is as a whole number and what you'll end up doing. If this was negative 5 plus a positive 3, that equals a negative 2, right? If it's just the whole numbers. So I should get an answer close to negative 2. Is that close to negative 2? Sure is. That's almost there, right? That's where we are. Okay, let's move down to number 10. Looking at number 10. Similar idea as the one we just did, except this time I have, looking at a whole number, 17 minus a minus 12. And whenever I'm subtracting a negative number, I can change this into adding a positive, right? So when we subtract the negative, it does the opposite. We're going to add a positive. So now when I look at this one, really what I'm doing is I'm saying, well, this really is 17 2/9 plus 12 1/3. To solve that, of course, I still need a common denominator. So I'm going to multiply this by 3 and multiply this by 3. So I end up with 3/9 for this part. And I add together. 2 plus 3 is 5. Keep my denominator the same. And 17 plus 12 is 29. So I end up with 29 5/9 for number 10. Okay? How are we doing? We're okay so far? Alright. Moving on to number 12. 12 is another good one. Alright, because what do we have this time? It's very similar to number 6 up above, right? Number 6 and 12 are very similar. Here I had a negative plus a positive. Here I have a negative plus a positive. So this, if I look at the whole number, this is negative 7 plus 15. If you remember last time, what we did is we said, well, let's rewrite this. Let's change the order and make this 15 minus 7 because I like that a little bit better than that. Okay? Have I done anything different? Nope. I just moved this to the other side. That's still positive. And if I think about mathematics, 15 minus 7 is actually 8. Okay? So I should get an answer here somewhere near 8. Let's take a look then at number 12. To do the subtraction, I move my big number on top. 15 5/6. And I'm going to subtract 7 1/4. Now in this case, I don't have a real easy to look at common denominator. So I could look at the least common multiple. If I look at my 6's, I have 6, 12, 18. Look at my 4's, I have 4, 8, 12. And I can see I have a match at 12. So my denominator is going to be 12 for both of these fraction pieces. To get from 4 to 12, that's times 3. So I'll do the same to the top. 1 times 3 is 3. And to get from 6 to 12, that's a times 2. So 5 times 2 is 10. I still have a big number on top, 10 minus 3, which I can do. So 10 minus 3 is 7. And I still have the denominator as a 12. That stays the same. And on the whole number part, 15 minus 7 is 8. So I end up with 8 and 7/12 for my answer for number 12. And again, like we predicted, it's pretty close to 8, right? 8 and a little bit more. So we ended up with. Let's look at number 13. Number 13 down here. Okay, similar idea, right? If I think about whole numbers, this is 6 plus -4. If I'm not worried about the fraction part, I have 6 plus a -4, right? So this is, the signs are different. I find the difference. Difference means subtract. 6 minus 4, and 6 minus 4 is 2. Now my answer is not 2, because I have a whole fraction part here, but I can set it up the same way as 6 minus 4. So let's do that. Let's do 6 and 1/8 minus 4 and 2/3. Okay, once again, I don't have a common denominator, so I can think about least common multiples. And if I look at my 8s, I know 8 is 8, followed by 16, followed by 24. 3, I have 3, 6, 9, nothing matching yet, 12, 15, 18, 21, 24. Yay, I finally have a match. So to turn the 1/8 into a 24, I'm going to multiply by 1, 2, 3. 1 times 3 is 3. To turn the 3 into 24, that is times 8. 1, 2, 3, 4, 5, 6, 7, 8. So I do the same up here. 2 times 8 is 16. So I'm looking good so far in the fractions, at least I think so. Now, my goal is to subtract. Can I do 3 minus 16? The answer is no. If I had 3 circles, I can't take away 16. It doesn't work. So my next step then is to come over to my next door neighbor, right, and to borrow from here. So it becomes 1 less, and I'm borrowing a whole. Well, this time I'm borrowing a whole 24 out of 24. Okay? Because it's a whole pie, and my bottom part, my denominator is 24. So 24 plus 3 is actually what? 27. So what I really have then is, I'm sorry, I'm running out of room here a little bit, so I'm going to erase this guy just for now. So what I really have is 27 24s and 16 24s. That's what my fraction pieces look like now. So let me rewrite it just for a second here. I have 5 and 27 24s minus 4 and 16 24s. Okay, so I just took the 5, 27 24s, and the 4, and I slid it down here just so we can see a little better. So now I can do 27 minus 16. I'm not sure what that is, so I'll set it up like this on the side of my notes. 7 minus 6 is 1. 2 minus 1 is 1. So on the numerator I have 11. My denominator is 24. And 5 minus 4 is 1. Okay. Can those reduce anymore? Not that I know of, so I'm going to leave it just like that. So I have 1 and 11 24s for number 13. 1 and 11 24s for number 13. Was that close to my estimate of 2? Sure, that's pretty close. In the right ballpark at least. Alright, let's take a look at number 14. For number 14, if this was just a regular old number problem, I would have 7 minus 6. And 7 minus 6 is 1. So I should get an answer here that's fairly close to 1. Let's take a look. I'll do 7 minus 6 and 4/9, stacking that up there. The first thing you notice, of course, is that I don't have a fraction here to subtract from. So there's nothing there, so I have to go to my next door neighbor, this guy, and I borrow from him. So 7 becomes 1 less, which is 6. And I'm borrowing a whole. Well, I want the denominator to be the same, so I'll just make it 9 over 9, because 9 over 9 is equal to 1. Now when I subtract, I do 9 minus 4, which is 5. The denominator stays the same. And 6 minus 6 is nothing, so I leave it as simply 5/9. And that's all there is for number 14. Let's do one final one, looking at number 7. in here together. Okay. Number 17, the setup. I have 12 plus a negative 14. When I have 12 plus a negative 14, my signs are different. So when the signs are different, I find the difference and I keep the greater sign. Right? This becomes like 14 minus 12, and 14 minus 12 is 2, but I keep the greater sign, which is negative. Okay? So that's what I'm going to do now, but I'm going to do it with the fraction piece. Okay? Let's look at number 17. So what I'm going to do, I'm going to stack it up the same way I did the whole number stack up. I'll do 14 and 1/8 minus 12 and 2/3. Even though I'm writing it this way, I have to remember that my answer is going to be negative. No matter what happens here, it's going to be negative. So if I want to put the negative right there so I remember, that might help you out. Don't forget that. Right? Looking at our notes, that has to be negative. So 1/8 minus 2/3. I had one like this just a few problems ago, right? Number 13. And for number 13, what would we say our common denominator was? 24. So I'm going to get to 24 and 24. To get here, it's times 3. To get here, it's times 8. So I have 3 minus 16, which I can't do. So what do I have to do? I have to borrow from the whole number and add to it another whole fraction, 24 over 24. So just like our last one, I have 27, 3 plus 24 is 27 over 24, and then 16 24s right there. So if I look at what I have left for real, I have 13 and 12. This part is now out of the picture, and my fraction part is right here. So 27 minus 16 is still 11 like the last problem, and the denominator is 24, and 13 minus 12 is 1, and it's all negative. So I end up with a negative 1 and 11/24. So kind of an interesting problem because, oh my goodness, it's the same solution as that one. Why is that? I don't know. Alright, so that's some homework help to kind of get you going here. If we look back real quick at the ones we didn't cover and you think about whole numbers, this one here is just like a 2 plus 1. Right? Nothing to really worry about or change. When I look at number 7, I didn't do it because it's just a basic 7 plus 9. You have to find a common denominator. Number 8, I think I did it, but I didn't write it down here. Right? We did 3 plus a negative 5. That's going to be a difference where you do 5 minus 3 and make sure your answer is negative. Number 9 is a 10 plus 5. No problem there. Number 11 is a 6 plus 12. No problem there. Number 15, this is a fun one. We have negative 8 plus 5. And we said let's change the order around so it becomes a 5 minus 8. Right? If I do 5 minus 8, signs are different. Not helping me out yet. So I have to find the difference. Difference means big number on top. Other one there. Difference means subtract. But which one has a bigger sign? The negative. So I should have a negative answer here with all that going on there. 16 is a regular 7 plus 8, no problem. And 18 is a 21 plus 15, no problem. So hopefully that gets you going a little bit and it helps you out. Good luck.